Hello everyone, myself Sumit Maheshwari working as an assistant professor in ABES Engineering College. Today I'm delivering a lecture on numericals on resonance, series and parallel both. So what is our first numerical? In a circuit, there is a R, L and C connected in series with a 100 volt 50 hertz supply. So we are making first a circuit. This is our R, this is L, this is capacitance C, are connected in series, and the operating voltage is 100 volt and 50 hertz. The value of R is 10 ohm, L is 0.2 Henry, and capacitor is 40 microfarad. So in such a way, our circuit is there. Now find out the resonating frequency. So resonant frequency FR, which is 1 upon 2 pi root LC. So in this way, 1 upon 2 pi, put the value of L and C here. L is 0.2 and C is 40 into 10 to the power minus 6. So after calculating this frequency, you will get the value of resonant frequency, which is 56.2697. After calculating by using calculator, this is our A part. Now move to the B part. Find out the current at resonance. So when we are talking about series resonance, our current is maximum Im, which is I square Im, which is V by Z minimum, because our impedance is minimum. So voltage is given 100. Z is only R because XL is equal to XC at this frequency, resonating frequency FR. So Z is only R. So 100 divided by 10, which is 10 ampere. And this is maximum. Now we are finding the power and power factor. So power is I square R and current is maximum. So that is Im square R Im 10 square into resistance 10. So which is 1000 watt. This is our power and power factor in a series resonance circuit. When XL is equal to XC, circuit nature is only resistive. And in resistive circuit, voltage and current both are in same phase. So the power factor is cosine angle between voltage and current. And there is no angle between voltage and current, then cos phi, that is cos 0, is equal to 1. Unity. So the power factor is unity at this resonance. Now we will talk about the voltage across resistors, inductor and capacitor. So VR, we are finding VR, which is I into R. Current is our 10 ampere and resistance is 10. So the VR is 100 volt. What about VL? I into XL. So I into XL, I is 10, XL is 2 pi. Now we are taking F no, FR, resonating frequency, because we are finding the voltage across resistor, inductor, and capacitor as at resonance. So by solving 10 into 2 pi into FR, that is 56.2697, we are calculating earlier, and L 0.2. So after calculating, you are getting 707.10 hertz, sorry, volt. Similarly, VC, I into XC, I is 10, XC is 1 upon 2 pi FRC. So 10 upon 2 pi FR, frequency 26.2697 into capacitance 40 into 10 to the power minus 6. So after calculating, this would be again the same, because XL is equal to XC. So VL also is equal to VC. And that's why we are telling series resonance is voltage magnification or voltage resonance. Voltage resonance, because our voltage across VL or VC both are equal, and that is quite larger than V supply. So V supply is just 100, but our VL and VC at resonance is 707.10 volt, which is almost 7 times. Now we are calculating half power frequencies F1 and F2. So F1 is FR plus R upon 4 pi L. So what is the value of FR? Which is 56.2697 plus R 10 upon 4 pi into 0.2. So after solving it, you will get 60.2485 hertz. Similarly, for F2, which is FR minus R upon 4 pi L, which is 56.2697 minus, this is 10 upon 4 pi into 0.2. This is basically F2 and this is F1. When we are talking about this FR, so this is F1 and this is F2 at resonance, and this is the bandwidth. So this is F2 and this is F1, and we are calculating F1 now, which is 52.2909 hertz. So in such a way, we are calculating these two frequency. Now we are getting half power frequencies, then we can find the bandwidth. bandwidth, which is f2 minus f1. So when we are subtracting this 60.2485 minus 52.2909, you are finding it is 7.956 hertz, or you are calculating this by R upon 2 pi L directly by using this formula. Now, the last part of this numerical, quality factor. So you are using either voltage magnification formula VL or VC upon V, or 1 upon R under root L by C. So by using this formula, because we have VL 707 and V is 100, so it is uh, the factor of 7.07, and it is unitless. So in such a way, we are getting all the uh, required results. Now we are moving our parallel resonance circuit. So there is a circuit R, this is L, and this is our capacitor C, which is in parallel. Let us suppose R is 25 ohm, L is 0.5 Henry, and our capacitor value is 5 microfarad. So you are calculating first the resonating frequency. So parallel resonant frequency FR, the formula is 1 upon 2 pi under root 1 upon LC minus R square by L square. We are putting the values. 1 divided by L 0.5 into C 5 into 10 to the power minus 6 minus R 25 divided by L 0.5 and square of this term. So after calculating this uh, whole expression, you will get the frequency 100.34 hertz. Now, what is the dynamic impedance of parallel resonant circuit ZD, which is L upon RC? So the value of L is 0.5, R is 25, C is 5 into 10 to the power minus 6. After solving, you will get the ZD 4000 ohm here. Now the bandwidth. So the formula of bandwidth is, which is delta F, is R upon 2 pi L. The value of R is 25. and the inductor value is 0.5. After calculating, you will get bandwidth 7.958 hertz. Now, the last part of this uh, circuit, quality factor. Q. Again, the formula is similar. 1 upon R under root L by C. So the value of R is 1 by 25 under root L 0.5 upon C 5 into 10 to the power minus 6. So by solving this, you will get 12.65. So in this way, you are getting the um, uh, knowledge about how to solve series and parallel resonance circuit. So these are our references, and this is our disclaimer. Thank you.